All right, here we are again. I am Kinetica, the physics unicorn, and I brought my friend over here, Squishy, the squishy unicorn, who frankly looks a little bit like a pig, but had to bring him along, so I'll explain why later. Anyway, let's correct your reading questions. All right, number one. How is energy defined in science? Well, it's the ability to move or change matter, which many call work. If you're moving or changing matter, you're working. So energy is the ability to move or change work. Now, you may think that's a kind of a weird definition. Doesn't seem very clear. There's a good reason. Because when it gets down to it, there's a little bit of mystery about that, about, the nature of energy. And many think it's really more about our language, that we just don't have good enough words and verbs and all the rest to describe energy. But some think that it's actually because the energy as a phenomenon is a fascinating thing that's kind of beyond our human brain's ability to get around. But yeah, so the best we can do is the ability to move or change matter. And actually, as you get into science, that winds up being better than it might sound to you right now. All right, the International System of Measurements unit for energy is the joule, also known as the Newton meter. And the two forms of energy, forms that energy may take, potential and kinetic. All other forms or types, types of energy fall in those two forms. What type of energy is the energy of a moving tennis ball? Well, kinetic. What is kinetic energy? Energy that is moving matter. I probably should have also just written mechanical right there. Should have probably said it's mechanical. Can I hold my phone and do mechanical energy? And mechanical energy is a kinetic form of energy. You'll hear them often used interchangeably, but kinetic is generally more a broader term than mechanical is. All right, so kinetic, energy that is moving matter. The kinetic energy of a moving object depends on its mass and its velocity, because the formula, kinetic energy is half of the mass times the velocity squared. A bowling ball in the picture, whizzing down the bowling lane at 4 meters per second, we get a velocity. If the mass is 7 kilograms, what is the kinetic energy? All right, kinetic energy equals half times the mass times the velocity squared. So half of 7, 3.5, times 4 squared. 4 squared is 16. What's 3.5 times 16? It's 56. And what's the unit? Joules. Dun, 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 dun. So here we go. Number 8. What is potential energy? Potential energy is stored energy. It's not actually in the process of moving or changing matter at the moment, but it could. Compare and contrast gravitational and elastic potential energy, and give an example of each. Gravitational potential energy depends on weight and height, also known as elevation, like an 80 Newton rock at the top of a 10-meter cliff, right? It's got a mass, it's got height, so it's got gravitational potential energy. Now, elastic potential energy is due to an object's shape and how it is stretched or compressed, such as like when I push the squishy toy in a few centimeters. There's elastic potential energy there now. That would push out. A diver weighs 500 newtons. The diving board is 5 meters above the ground. What is the diver's gravitational potential energy? Well, gravitational potential energy is weight times height. 500 newtons times 5 meters. So we got Newton meters, which is 2,500 joules. Why does food have potential energy? It is stored in the chemical bonds that hold together its atoms and compounds. It is also called chemical potential energy. brings us to the next page and the 7 types. It says form at the top. I should change that to types because often we use the term form to describe kinetic or potential, and types to be all the different types of those potential or kinetic forms. Because mechanical is a kinetic form, chemical is a potential form, electrical kinetic, electromagnetic kinetic, thermal kinetic, sound kinetic, nuclear potential. All right, so here we go. Mechanical, it's in the form of movement. My pen, well, right when I was writing that, I was thinking, well, my pen is moving, therefore it's mechanical energy. Then I had chemical, it's stored in atomic bonds, like food and batteries. Electrical, moving, well, actually, some of you probably don't realize that in batteries, it's actually the chemicals, the interaction of chemicals in the battery, that's getting the electrons flowing. So batteries, when the chemical energy is released, it turns into electrical energy, which is the actual moving of electrons, like in solar cells or outlets. You know, when you plug something in, you're accessing a flow of moving electrons. Electromagnetic, it travels as waves, and so even though it looks like it has the word electricity in it, it's something different. It's electromagnetic, and these are things like light, radio waves, microwaves, gamma waves. The whole electromagnetic spectrum is a form of energy. Thermal, microscopic moving matter. You may not realize this, but when things increase in heat, they increase in the amount of microscopic motion that's happening in them. So anything that's getting hot. Sound, vibrations and matter, like my voice. Nuclear, stored in the nuclei of atoms due to subatomic forces, such as those that are used in nuclear power plants or in the infamous bomb. So, identify 3 different forms of energy represented by the picture. Well, kid probably ate some food. The food's releasing the chemical energy into kinetic energy, the mechanical energy of the motion of its lips and fingers and lungs. I should have put that in there, the pushing out of the air. And then that results in vibrations that are coming out of the trumpet. Until next time, this is Kinetica, the Physics Unicorn.